Hey everyone, and welcome back to the Firefighters Podcast, where we seek to develop, inspire, and motivate the world of the emergency services operator through a series of wide-ranging conversations. Now, before we go any further, just hit that rate, follow, or subscribe button on whatever platform you're listening to. It's a key performance indicator for us and helps us reach even more people. Now, here's what we've got for you today. Okay, folks, here we go with another episode of our Firefighting Foundations series, and this one we're going to go into, certainly for our city boys and girls, one of the most critical, but often not necessarily misunderstood, but rarely gone into in any massive detail. I've only ever had a few presentations on this, and I've had to do deeper dives with international guests, because we're going to be talking about modern high-rise firefighting, and specifically pressurized staircases. Now, for those of you listening in the UK, these systems are increasingly part of the buildings we attend. They should be really in all of them these days. They are there to protect lives, to protect us, and make the job safer. But as with everything in fire, the devil is in the detail. So if we don't understand how these staircases actually function, what makes them effective, what compromises them, and how they interact with the fire behavior, we risk turning an engineering safety feature into a liability. So we're going to have a little bit of a dive into what pressurized staircases are and why they exist, the science of pressure, flow paths, and smoke movement, how these systems are designed in the UK, the operational challenges for firefighters. Going to put a few references to some real case studies where pressurized staircases work well or didn't. And finally, the tactical lessons we need to carry with us every time we step onto the stairwell. So let's get into it. Firstly, why do staircases matter? So let's start with the basics. In any high-rise incident, the staircase is the single most important vertical space in the building. Its route is the residents' way to escape. It is their way out. It's their way to safety. It's the route firefighters use to get in. It's where hose lines are laid out, where they're stretched, where command posts are set up, bridgeheads, and where resources are staged. In almost every high-rise incident, the staircase becomes the backbone of all of our operations. But think about it. What else is the staircase? Well, firstly, it's a tall vertical shaft that connects the entire building together. So in fire behavior terms, that's a potential chimney. If smoke and hot gases find their way in there, they will rise, they will spread, and they threaten every single floor above. That's why staircases are protected by fire-rated doors and walls, and why in modern construction they are increasingly fitted with pressurized systems. The staircase is our lifeline and the lifeline of everybody in the building. If it fails, the whole building is compromised. So, what is a pressurized staircase? So what do we really mean by this? At its core, it's a smoke control system. Think of it that way. The idea is simple. Pump fresh air into the stairwell to raise its pressure above that of the fire floor. That way, when doors are opened, air flows out of the stairwell into the fire area rather than smoke being pulled in to the stairwell. The components usually include some kind of mechanical fan, often located at the roof or plant level. There's ductwork feeding air into the stair at one or more levels. There'll be some automatic dampeners probably that release any excess pressure. And you'll probably find a control panel that'll allow you to manually override it if needed. Target pressure varies, but it's typically around 50 pascals. Might not sound like a much, but it's enough to stop smoke sneaking through door cracks. Modern designs often integrate pressurization with other smoke control systems like lobby extrication to ensure smoke is being removed from the fire floor as well as excluded from the stairs. It's a simple idea, but when fire dynamics come into play, it obviously gets a little bit more complicated. So, the science, pressure, flow paths, and smoke. Let's talk a little bit of fire science, and we're not going to go too deep. Every fire produces smoke. I think we can all agree with that. That smoke is hot, it's buoyant, and pressurized compared to the cooler air around it. It wants to spread, it wants to grow. It will move through an opening, like a door, a crack, a shaft, following pressure differences. A stairwell is a huge potential pathway. If it's not protected, it can become the main flow path, pulling smoke upwards and contaminating every single landing and floor above it. Pressurization flips that dynamic. By mechanically raising the air pressure in the stairwell, we create a barrier. Instead of smoke moving in, clean air pushes out. But here's the catch. If doors are wedged open, the pressure collapses and smoke flows in. If the system overpressures, doors can become difficult to open, delaying resources or our firefighter entry into certain areas or floors. And if wind is acting on the building facade, the external pressure can overwhelm the system, forcing smoke into the stair despite it being pressurized. And here's where fire behavior comes in. In a ventilation control fire, very common in modern sealed apartments, introducing air, whether by fan or by opening a door, or even the stairwell system itself, can suddenly increase the heat release rate. That's why door control and tactical ventilation discipline are so very critical. So why does this matter to us? So let's frame this in our firefighter terms. Egress. We all know what egress is. This is residents. Their lives depend on that stair staying tenable. If smoke gets in, visibility drops, toxic gases accumulate, and panic spreads. We've seen this in a lot of incidents around the world, and obviously some here in the UK, which have been heavily documented. Access. Staircase is our highway to the fire floor. If it fills with smoke, you lose your main route. You might be forced to fight for access before you can actually fight the fire. Exposure. Modern smoke is toxic. It's got hydrogen cyanide, carbon monoxide, benzene, all sorts of nasties. Keeping the stair clean reduces firefighter exposure, even if you're in BA, because it's still going to get into your kit. Depending on what kit you're wearing, it's still going to get into your body. And then operational efficiency. So when the staircase is intact, hose deployment, casualty handling, and communication all work better. When it's compromised, everything slows to a grinding halt, and we get that fog of war, we get that confusion, that miscommunication. So, the engineering, how the system actually works. Let's go deeper into those mechanics. So we've got the fans and the supply. These are large fans, like we said, usually at roof level. They feed air into the stairwell. Target pressure, we touched on earlier. Typically, systems are designed to hold around 50 Pascal differential, enough to stop smoke, but not enough to trap people inside, i.e. they can't get the doors open. Got some relief dampeners. These prevent the system from overpressuring, and without them, like we said, doors can require excessive force to open. Then there's an activation system. Some systems are automatic when the fire alarm trips. Others require manual activation from us, from firefighters, overriding the panel. Here's a little tip. Always know where the control panel of fan rooms are. So when you're doing your 7.2D visits, your risk visits, whatever it is, find them, because you might need to override them, reset, or even shut the systems down in certain scenarios. So make sure you know where they are. Challenges and pitfalls. Let's talk about what can go wrong. So overpressurization, spoke about that a little bit. Doors, too stiff to open. That's what that means. So delaying resources. Imagine a resident in their 80s or their 90s trying to push against a door that's held shut simply by air pressure. That's why relief dampeners are critical. A little bit of door discipline. The biggest weakest link is unfortunately us. Every time a door is wedged open, smoke has a pathway. A few careless wedges and the whole system can begin to domino collapse back on itself. Wind-driven fires. We spoke about this recently on the Fire in the Sky episode. So in exposed high-rises, wind pressure can work against the stair pressurization. Again, some FDNY cases, stairwells were overwhelmed, despite the fans actually working. Maintenance and testings doesn't necessarily come into us, responsible persons of the buildings. These systems only work if they are tested and maintained. Faulty dampener or broken fan, or just poor comms, can leave the stairwell unprotected. It is covered by a lot of standards and regulations. It's not just good practice, it is in law and guidance. There's a core standard for stairwell pressurized systems. There's an update standard on stricter performance criteria. And there's a few BS EN standards. I'm not going to try and misquote them here in case I get them wrong, because it's not my area of expertise. But, there's one certainly, 9991, I think it is, requires pressurized staircases in residential buildings over 18 meters with a single staircase. So in the UK, high-rise jobs expect to deal with pressurized staircases. They are here and they are here to stay. Fire behavior. So fire behavior in the stairwell. If the stairwell fails, comes a flow path. Smoke rising through 10, 20, 30 floors is a lethal scenario. That's why stair pressurization is considered one of the most effective smoke control measures in high-rise design. But we need to remember staircases don't exist in isolation. They connect to fire compartments, lobbies, doors. The moment those doors open, the dynamic changes. Pressurization helps, but it isn't a magic sticker, sheep dip, cure-all. It relies on firefighter behavior, door discipline, and understanding flow paths. This is why that air track management is so important. So go and have a look at some case studies. You can see some wind-driven fire examples in the 90s in FDNY. Several firefighter fatalities occurred where stairwells were overwhelmed by wind-driven conditions despite normal tactics. There's some UK high-rise training fires. Some CFBT instructors repeatedly stress the stairwells can become contaminated simply by poor door management. Propping lobby doors open for hose runs is one of the fastest ways to compromise the system. And then obviously we look at Grenfell. So while not specifically a pressurized staircase, stairwell integrity was a major factor realistically in the evacuation difficulties. It highlighted nationally how critical it is to maintain stairwell conditions for residents. So some tactical takeaways as we wrap this one up. A few things to remember. Respect the stair door. Every unnecessary opening undermines the system. Expect a bit of resistance. Pressure can make the doors harder to open, but don't misdiagnose those as locked doors. Sometimes you've got to pull a little bit harder on them. Know the system. Your 72D visits, familiarize yourself with it. Fan rooms, overrides, vent points. Make it part of your familiarization. Make sure your crews know where to go. Coordinate your ventilation. Any tactical venting must be done with the stair pressurization, not against it. Monitor the air quality. You see this in some of the high-rise teams, some of the stairwell protection teams. So carrying air detectors, air monitors, even in clear stair. It's good to have that discipline to check for leaks in smoke. Preserve the lifeline. Always think, if the stair goes down, where do my crews, where do the residents actually go? This is the only way out. So pressurized staircases can be your best ally or your most dangerous blind spot. When it works, it keeps routes tenable, preserves egress, buys time for us, for rescues, for firefighting. But it isn't infallible. It relies on design, maintenance, and above all, a bit of firefighter discipline and knowledge. So next time you arrive at high rise, don't just look at the fire flat, look at the staircase. Is it pressurized? Is it holding? And how does that change your tactics today? Okay, short one. Hope you found it useful. That's it for today's episode. If you found it useful, share it with your crew, share it with your watch, or anyone you know who might be facing high-rise jobs. Don't assume they know it. Assumptions are the mother of all getting it wrong. So you can listen to this privately. Listen to it in the car. People think you might know it, maybe you don't know it, maybe you needed a reminder. Check the episode notes. I'm going to try and produce a document for you to read this if you want to read it. Don't know why you'd want to read it. Otherwise you wouldn't be listening to the podcast. And always, just stay safe, stay smart out there, and I'll catch you next time for another Firefighter Foundations episode. See you next time. Well, that's it for today, folks. Hope you took a lot away from that episode. We started the Firefighters Podcast to develop, inspire, connect, motivate, represent, and most importantly, celebrate the world of incredible emergency services operators and the wider sector through this series of wide-ranging conversations. We really love creating this podcast and bringing it to so many people. Did you know you can also find these on YouTube? We do a lot of video podcasts now. You can head over to our YouTube page and follow, subscribe there. And as a final ask from us, whatever platform you're on, please rate the podcast. It really helps us as a key performance indicator to reach more and more people. I've been your host, Pete Wakefield. This has been the Firefighters Podcast. And wherever you are in the world, please stay safe, be happy, live with intention, and where possible, please remember and support your firefighters and first responders. I'll see you next time.